Did you know that on Mount Everest, water boils at just 68 degrees Celsius instead of the usual 100 degrees? Imagine trying to make a cup of tea, but it never gets hot enough to steep properly. Weird, right? It's not magic, it's physics. And if you're thinking, why does this even happen? The answer is all about how the air around us changes with altitude. But here's the twist. This boiling anomaly isn't just a cool Everest fact. It's a critical clue that scientists use to understand pressure, altitude, and even how life survives in extreme environments. So, if you've ever wondered why cooking gets harder the higher you go, or why climbers pack dehydrated food instead of pasta, stick around. This is going to blow your mind faster than Everest boils your water. All right, let's talk about boiling water. We've all done it. You fill a pot, turn on the heat, and wait for those bubbles to form. It's so simple we rarely stop to think about what's actually happening. Here's the science in everyday terms. Water boils when its vapor pressure matches the surrounding atmospheric pressure. At sea level, the atmosphere presses down hard enough that water needs to hit 100 degrees, 212 to generate enough vapor pressure to escape as steam. But here's the kicker. As you climb higher, there's less air pressing down on you. The atmospheric pressure drops, and water doesn't need to get as hot to boil. That's why on Everest, water boils at a shockingly low 68 degree, 154 degree. Sounds cool, right? But there's a catch. It makes cooking a serious challenge. So why does this matter? Well, it's not just about bragging rights for climbers. Boiling water is a survival essential, especially in extreme environments. It's how we purify water and cook food. But on Everest, boiling doesn't mean the water is hot enough to kill harmful bacteria. And cooking? Forget about it. Food that needs high heat, like pasta or rice, won't cook properly because the water never gets hot enough. Climbers have to rely on pre-cooked or freeze-dried meals instead. This boiling point phenomenon isn't just an Everest quirk. It's a challenge for astronauts, scientists working in high-altitude labs, and even pilots flying at extreme altitudes. How do we adapt to this pressure problem? Let's dive into the science and solutions. The Earth's atmosphere is like a thick blanket of air that gets thinner as you go higher. At sea level, you've got the full weight of the atmosphere pushing down on you, about 1 kilogram per square centimeter. But climb a mountain, and there's less air above you, meaning less pressure. On Everest, the atmospheric pressure is about 1/3 of what it is at sea level. That's why water boils at just 68 degrees. It doesn't need as much heat to push against the reduced pressure. Boiling isn't about how hot water gets. It's about how much energy the water molecules need to escape as gas. At sea level, those molecules need a lot of energy because they're fighting against high atmospheric pressure. But on Everest, the air is so thin that water molecules escape more easily. Less energy, lower boiling point. Here's where things get tricky. Cooking relies on heat transfer, and at 68 degrees C, the heat isn't sufficient to properly cook most foods. That's why climbers stick to instant noodles, freeze-dried meals, and energy bars. Even worse, water at that temperature might not kill all pathogens, making it unsafe to drink without further sterilization. The same principles apply to airplanes and spacecraft. In pressurized cabins, engineers have to simulate sea-level conditions to ensure food and water behave as expected. And in labs or industries operating at high altitudes, scientists have to account for this pressure difference in their experiments and processes. Here's the big reveal. This boiling point phenomenon is a perfect example of how small changes in pressure can have massive effects. It's not just about Everest. It's about understanding the relationship between heat, energy, and pressure. Concepts that apply to everything from weather systems to industrial engineering. Without this knowledge, we wouldn't have altitude-ready survival gear, space-ready food solutions, or even reliable weather forecasts. What seems like a quirky Everest fact is actually a cornerstone of physics, chemistry, and engineering. So the next time you watch water boil, think about how much is happening beneath the surface, literally. From Everest to everyday life, the science of boiling points teaches us about the invisible forces shaping our world. It's not just a mountaintop curiosity. It's a window into the fundamental laws of nature. And hey, now you know why instant noodles are the real MVPs of high-altitude adventures.